going to share on the screen with you, okay, there is a table. Now I'm going to ask you a couple of questions from the table, take the answer from the book and tell me the answer. Let's start with Halima first. Halima, how are you going to define the volume of a solid?
It has a fixed volume.
Very good. And Umama, now your turn. Your question would be defining the volume of a gas.
It has no fixed volume.
It has no fixed volume, which means, let's complete the sentence given in the book.
No fixed volume expands to fill the container.
Do you understand what this phrase means, Umama?
It means that the gas expands and to fill the container with
Right, right. This means it has no fixed volume, unlike solid and liquid. Why? Because it can expand. It can always expand to take as much space as it can. That's why what happens then that whenever there is a gas, it quickly travels or expands from one certain point to the rest of the points in the room, in the place, in the container, wherever there is any available space. So it actually takes up all the space it can. That's why whenever our mothers are cooking very good scented food for us, actually the smell goes all the way from the kitchen, smell in positive terms, not in negative repercussions, uh, all the way from the kitchen to the living room or to the dining room or to the other parts of the home, so that we would know that some really, really delicious food is being prepared for us, right? So that's how gas moves from one point to another point, expands to fill the container, expands to fill the rooms or whatever available space is there. Do we get the idea, Umama, Halima? And that goes for
yes.
the rest of the class as well. Anybody having any questions from this table? Anyone? Okay. For new students, including Halima and Umama, you are supposed to go and study the whole left side of this page as well as the table. That is what we are done with so far. And if you have any question, you can ask me that in tomorrow's class, right? Let's move on to the next portion of this page. I mean, the right-hand side of this page. So all of the students are asked to open up page number 22 on their books. Right-hand side column. Let's quickly go with a few lines and then we are going to end the class. Starting with the first line on the right-hand side, gases are easy to squash, to compress, to press to a smaller volume. Liquids, on the other hand, are slightly compressible and volume of solid is unaffected by the change in pressure, right? We've studied that previously. That is compressibility. I was just repeating the lines because we have studied these lines in our previous classes. Now, changes in physical state. Large changes in temperature and pressure can cause more dramatic than expansion and contraction changes. Now, this may cause a substance to change its physical state, which means we can always convert anything from solid to liquid or liquid to gas or from gas back to liquid or from liquid back to solid, which we are actually doing on daily basis. So let's ask Arich. Arich, can you give us a
Yes,
daily life example of converting some state of matter into any other state of matter? A daily life example, please.
um, sir, I can, sir, when we wash clothes, we hang them to dry up, and the water evaporates in the air.
Very good. Okay, Ibrahim, another example from daily life when we are changing one state of matter into another.
The ice.
Ice, right. We're converting on daily basis using our refrigerators and deep freezers to convert water into ice, and then we use that ice with our solid foods or with even our cold drinks, right? So another student, this time Zoya. Zoya, is preparation of ice cream a change in physical state?
Sir, can you repeat the question?
Is preparation of ice cream a change in physical state?
Sir, yes, because it
Yes, very good. Very good work, Soya. Yes, because we are converting a liquid phase into a very delicious ice cream, right? So going with these simple processes at home, we are actually changing the physical states. Clear? So the conversion of physical states is actually examples of our daily lives. So what we are going to do is that from those conversions of physical states, we're going to study a few definitions such as melting, melting point, freezing, freezing point, sublimation, all of these definitions tomorrow. All right. We have hardly a minute left. If anybody's attendance wasn't marked, please let me know. Otherwise, I'm going to end up the class.
Excuse me, sir. Which chapter have we will do in this class? 8th class, C-1.
Beta, in 8th class, we're going to finish up chapter number 2, 3, and 4. And whatever part of chapter 5 we can, we will finish that, try to finish that up too. We usually go with 4 chapters or 3.5 chapters in C1 class.
Okay, thank you, sir.
Welcome. Okay, class, Halima, do you have a question?
Homework?
No homeworks for today. You may cover up your previous part, no homeworks for today, beta. Okay? We have a few seconds left, so I'm going to wind up the class. Take care, students. Get ready for the next class. Allah Hafiz.
Allah Hafiz.